Alright, this is where I left off in my last video, and what I was getting ready to do was solve the system of equations. Now this one is actually a lot easier to solve if you approach this a little bit differently. This will bother some people, but there's two ways of doing this. One way is a little bit faster, for sure. You could very well distribute and create these two other equations, 2r plus 2c, and you could distribute here and create 15 equals 6r minus 6c. I am not going to do it this way. You can. It will create a lot more work because if you look and you try to add these together, nothing falls out. What I am going to show you guys how to do is, let's try to make this a little bit easier on ourselves. And what I'm going to do is I'm going to rewrite both of these equations, and underneath here I'm going to divide by 2 on both sides, and I'm doing this in red so you guys can see it. So I'm dividing by 2. What that does is it creates a whole new equation, and I'll write it right down here. 7.5 equals r plus c. I'm going to do the same thing here, except I'm going to divide by 6 on both sides. When I do that, it creates 15 divided by 6. 15 divided by 6 is, let's bring up the calculator so you can see, 15 divided by 6, 2.5. So you guys can use your calculators, and I showed you how you can do that on the calculator. So we'll get 2.5 equals r minus c. Now we can do that because both sides are being multiplied by this whole amount. Can't do that unless that was in parentheses and the whole thing was being wasn't being multiplied. So we can do that because those are all in parentheses. Now look what happens. This makes the problem a lot easier to solve by elimination. So I can add, I get 2r, I can add these together and I'll get 10. I'll divide by 2 on both sides and I get r is 5. What that stands for, the boat, the rate of boat is 5 miles per hour. And then I'd have the rate of the current to figure out yet. Now it is going to be much easier for me to just choose one of these two equations to plug this back into rather than going back to one of these original ones. So I'm just going to use the 7.5 equals r plus c, and I'll plug in my r value, and I'll end up getting that c is 2.5 because I'm going to subtract 5 off both sides. So I now know that the current has a rate of 2.5 miles per hour. So those are my two answers. And actually I didn't answer this question. What is her rate and the rate of the current? Oh, I did answer both questions. I was thinking I only had to answer one. So when I'm done, I went back and reread the question to make sure I'd actually answered it correctly. Let's try another one of those. We're going to first create a chart. Probably move through this one just a little bit faster than I did in the last example. I've got distance equals rate times time. I have an airplane this time, and the airplane takes 3 hours to fly 360 miles. Notice I'm putting that in the distance, and this is the time. With the wind, so I'll put with the wind here, and this would be against the wind. It takes 4 hours to make the return trip against the wind. You're still going the same distance. With the wind means that I'd have the airplane speed plus the wind, and against the wind means I'd have airplane speed minus the wind because I'd be going slower. So my two equations would be 360 equals 3 times a plus w, and then I have 360 equals 4 times a minus w. Again, I'm going to solve this a much easier way by dividing each side by 3. So if I divide by 3 on both sides, I get 120 equals a plus w. Here I'll divide by 4 on both sides, and I get 90 equals a minus w. I'm supposed to find the wind and the airplane speed, but again, I'll have to finish this in the next video.